Happy to be here, and thank you so much, NASCOM, and thank you, dear friends, for having us here. This is my second time in Bhubaneswar, so loving it. Well, I've been asked to come back from my olden days of Western Digital, which is like 4 years back when I was leading the country. So Shankar, it's all my job is to ask questions, and yours is to answer, right?
It's pleasure is mine.
So we're going to talk about semicon and the innovation that lies therein. All of you that you're holding your devices in the networks, we all know it's powered by semicon, right? Is there anyone in the room who believes it's not? Please raise your hand. You'll save us the questions later, and you'll save us the job of keeping you awake. So you know all that you're holding. My partner is sitting here and holding the device, so that's all powered by semicon. We know that. We also know that from what I witnessed and from what I've heard, the stories of a very humble transistor to now completely cutting edge nanotechnology, and everything is getting infused. So Shankar, what we're going to discuss is there's AI in chip, there is edge computing, there's everything that we talk about is now innovating. And in semiconductor, by the way, innovation is not a choice. Yeah. It's a necessity. If you have a doubt, please go read Google and you will know why that's a necessity. The nanometers, the shrinking that's happening, you don't have a choice. You can't be on an old node and and you just know the world is going to pass you by. So you know that's a necessity and that's what you need to do. So we are talking about an industry where this is the core. I was reading the stats, and when you look at the entire world, we are talking about this too being $1 trillion economy. We are about 500 billion or somewhere. So Shankar, tell us as to what's the scope worldwide? Where are we going with semicon and what's happening? What are some key trends that you see?
Yeah, just look back. We use our cars every day. We use our mobile phones every day. Just look at the car. What do you think the content of semiconductors is going to be? It's like a whopping $1,200. A car has something like $1,200 worth of content today. And if you want to use, it starts from your, wipers, it starts from your EV, it starts from your in-car entertainment. So everything is kind of going into it needs semiconductors to be powering them up. So if you look at, this is just one industry I talked about. So you can talk about the mobile industry, you talk about the IT sector, the industry there, the military segment. So I think the list goes on, and semiconductors touches every part of these segments. And if you see, the challenges are growing more and more in terms of more integration, in terms of more performance. That is where, if you see, the requirement for semiconductors has gone up. The innovation becomes kind of a necessity. If you don't innovate, I think you're going to be left out. Like I was, just discussing some time back, is there were over like 50, 60 big, semiconductor companies, but for lack of innovation, many of them don't exist now. There's a lot of aggregation that has happened in this particular segment. So today you have a few players, and they are at the cutting edge. And whether you talk about AI, you're talking about even ML, your defense business, big data, everything needs semiconductors to be there if you really want to have a good kind of, an analytics that needs to be done out of this. And of course, hand in hand with the software, it becomes, one of the key essential segments that we need to invest on. So coming back to your question, on the $1 trillion market, it's actually kind of, doubling in 6 years. In 2024, it's something like 500 trillion. And this is kind of doubling here. And all the key drivers for this is all this AI, you have this data centers driving this, the automotive. These are the segments that are driving this. So it's not, it's not a very, something that no one knows about it, what is driving this, but it is there, and, this is going to stay.
You're right. I mean, everything is driving it in clearly. But if you talk about the role of material science, I mean, that's what is very fascinating, right? Yeah. That in itself is a science that, gets extremely well applied here. And you're talking about now germanium and other things coming with, talk to us about that. What do you see as that scope? And where does India lie within that? Okay. And obviously, we were talking in our, early on conversation about lithium ion to say how China has it, we don't. And some of that raw material dependence and also becomes your core, right? Okay. And some nations succeed more than where India is.
Yeah. So today, I think if you look at the demographics of India, 50% of the working population in India are below the age of 30. So if you look at it, India probably has the highest working population, all young population, which means they are the ones who are going to sustain. And it's not, a kind of a myth that India is the number one market for smartwatches. India is probably the number two for mobile phones. So it's right up there because, the kind of disposable income that is there is going higher and higher. And if you look at the middle class today, they form something like 400 million of our population is the middle class. The 400 million is one US country for you. So you have an entire country that is available as your available market. And these are going to be the growth drivers. And the driving force behind that is going to be the semiconductors. So if you look at it, while globally that we talked about the semiconductor business going from 500 million to 1 trillion, we are going to see India going up to 100 billion from 27 billion now. So it's like 4 times is the growth. And the drivers are pretty much the same. It's going to be again the mobile phones, the AI, intelligence at the edge, and things like that. But the question that comes is, how is innovation going to cope with, as far as these developments are concerned? So like you rightly pointed out, today, majority of the parts, they are all made on the silicon. Silicon is the base that is used for manufacturing all the semiconductors. There are newer technologies that are coming out, like silicon germanium is one technology. And for, if you're looking at very high-speed application, base station, which needs very high power and things like that, you have gallium nitride is another GaN technology, that's another one which is evolving. So as the semiconductor, the processes in terms of the geometry of the semiconductors are going to come down, you need to innovate even as far as the chemistry is concerned. So it's a two-way thing that is going to be driving it. One is on the process, which is the geometry that is going to drive the semiconductor business. The other one is going to be on the chemistry that is going to be used. So you'll see more of such things coming out, as far as, the semiconductor innovations are concerned. So coming back to your question on the lithium-ion batteries, lithium-ion batteries are typically used for, any application. It could be for the energy storage. It could be in the EVs, it could be going into the cars. It could be like, an inverter that you use at home. Or it could be anything like an energy storage system. So everywhere you need lithium-ion batteries. And even there you see a lot of chemistry evolving. You have lithium iron phosphate is one of the technologies. You have lithium, different, combinations of lithium with many other chemicals which are being used for coming up with new battery topologies. So, if you see here, semiconductors go hand in hand there as well because a battery pack needs to be powered by the semiconductors. So the many semiconductors supporting and monitoring these cells is going to make you the battery pack which are going into your EVs and many other applications. So these are all, evolving technologies which I think, any company for that matter needs to look into how the process and the chemistry are going to evolve over time.
Great, Shankar. You clearly know the subject extremely well. So 100 on 100 on that one, right? Super, very well answered. Do we agree? If you're listening, say yes. If you're not, then that's fine. You continue powering your handheld device. That's okay. Thank you. I like the gentleman in the front. It goes back to school ages. People who sit in the front are always the ones who are avid listeners, right? And then there's a huge population of backbenchers. Do we have a shout from the back? Are you listening to what Shankar just said? There's a huge role for chemistry and material sciences. Yeah. We'll continue to focus on the front. Shankar, now coming to India, right? We're talking about Gujarat.
Yeah.
And it's a very honest question. There's no politics behind this, right? Gujarat being the hub for semicon. Of course, Bangalore is never far away. Karnataka is never far away. But we're talking about NXP coming in, Sanjay, Micron coming in. We're talking about Adani coming in with a Israeli firm. And for fab is a very big deal, right, in a semicon. And it's a huge, huge money involved. We're talking about billions of dollars. And here we're talking about India just being $1 billion industry. And there we're talking about $8-9 billion of fab just going into one fab investment. How do you think the economics will play out for India? And when I say economics for India in a semicon, what do you think are the challenges that we as a country need to plug? We got clean room, uninterrupted water supply, electricity, clean water. How are we going to develop the ecosystem for that? So it's a layered question. Take your time and then answer.
That's a very good question, I would say, because I think that's a lot of questions packed into one question. So let me tell you, I think, Gujarat obviously took a head start, as far as the semiconductor manufacturing is concerned. When the government announced the subsidies for putting up semiconductor plants, Gujarat took the leads. And there are other states also, they are not too far behind. For example, Assam has also they have also investments there. Bangalore is, Karnataka is talking about it. So every state is going to follow suit, I think. So which is going to be very evident. And we have seen big kind of establishments who have, put in their stakes to set up fabs into India. So the question is, are these fabs going to really be able to cope with, the developments and the challenges that are going to be there from the end market segment? That's going to be a question, because you need capability for supporting higher nodes. I talked about geometry. So if you're talking about geometry going down, you need higher nodes to be available. Are they in a position to invest into these higher nodes? Yes or no? That time will tell. So we need to look into that. Apart from that, like you mentioned, uninterrupted availability of water is there. And if you just go back 3 years from now, COVID taught us a lot of things. At that time, I was just joking with Supria, that I used to say that, I worked for a semiconductor company for about 25 years. So somebody asked me, what is semiconductor? So I said, we make chips. So they said, do you compete with Lays and others? So I said, this is a different one. But post-COVID, everybody knows what is semiconductors, because semiconductor shortages hit everybody's life. For a car, you had to wait 6 months for getting cars. And for everywhere, wherever the electronics was, involved, you had a lot of waiting period for that. Many companies, healthcare products got delayed because semiconductors were not available. So companies like TSMC, they were not having any capacity. As soon as we came out of that, the TSMC was kind of overcapacity. All the fabs were, hitting overcapacity. So coming back to the Indian scenario, you have, in the semiconductor industry, you have your ups and downs. The demand goes up really high. And next, maybe few months, few years, you'll see that the demand is low because of excess inventory or, availability of finished goods and other things. So everybody, gets into a situation where the semiconductors procurements are put on hold. So having invested, so much of money into semiconductor fabs, how are the companies going to cope with continued utilization of the fab is going to be a challenge. But obviously these big business houses would have worked out the plan for themselves. And some of them have their own captive requirements even. They have automotive business, they have telecom business. So many of these big industry houses, they have their own captive businesses who can survive. But those who are just putting up pure, semiconductor plants, how they are going to cope with this situation of, this varied demand, happening year after year is something which will be good to see how they are able to manage those situations. So in a nutshell, there are going to be a lot of challenges, but then, if India, becomes independent in, as making a semiconductors for themselves and for the world, then I think the economy is definitely going to flourish. And today, India has the highest GDP if you look at it. And that is definitely going to, kind of push India's GDP upwards.
I like your answer, Shankar. I'm going to push you a little bit more here. It's a very media-trained answer to say India has great opportunities, some challenges, and maybe if all goes well, it'll be a bright, sunny day.
Yes.
I'm going to ask you to say two things, very crisp. What are our chances? We've dealt with ISA, we've dealt with other organizations. We know the kind of lobbying that's happened, and we haven't seen any movement in a semicon from India. We've now got a lot of buzz. Do you think there's more noise than signal? Would you place a bet on India if you were to invest on India being a semicon destination? One of the many. Yes or no?
See, if you look at it from a, semicon destination, if you are looking at it from a fab.
Fab, yes.
Yeah, if it is only a fab, then you should have a clear-cut path. make in India for the world has to be there. If you can do that, meeting all the quality standards, meeting all the supply chains, kind of challenges, then some of the business houses can, make it there. But what I would say is the safer bet is to look at something like an OSAT facility, a test and assembly. This is, the fabs already produce all the dies and other things. But if you want to package it and if you want to test it, these are some things, which are lesser risky. So if you look at countries like Malaysia, Singapore, and many of them, they have a whole lot of these OSAT companies that are there. So these could be, the investments are relatively low, and these could still meet the requirements of the semiconductor industry. So the first step I would say is that to make sure that you get into the OSAT facility, make sure that you build up enough infrastructure and equipment for doing the assembly and the test, and then jump into this fabs. And even if you jump into the fabs, you have to start with the lower nodes before you actually, hit the bigger nodes.
I love that answer. It's a long journey. Just by investing 10 billion, parking aside, and doing PLIs, we're not going to get there. It's a long journey. It's taken decades to get there, and I think it's about time we start. And what you're saying, Shankar, is be part of the global supply chain. I think we today aren't there at all. But you're saying it's a very complicated global supply chain, and be part of that, and then move your way up. Is that Absolutely. A fair way of summing it?
Absolutely. I think today global supply chain is a big challenge. So for example, if you look at any electronic product, there'll be at least hundreds of electronic components go into that. And even if one of the components is not available, it's not going to go out of your factory. So managing it is something, really, it's a big challenge. Very few countries, if you look at China, Japan, they have all kind of mastered this. They know how to, play the game. So I think India needs to get there. I think meeting those global supply chain requirements is going to be an essential part of, a success as far as the semiconductor innovation is concerned.
Perfect. We're talking about semicon, but we're talking it more like a horizontal. And it's got its impact across so many different industries. You keep reading and there's not a single industry that doesn't get touched by, right? You talk about electronics, talk about automobile, talk about anything, and it cuts right across. Which, according to you, are going to be few sunrise industries that the impact is going to be a lot more, and probably a lot more semiconductor innovation will happen there?
If you look at it, one of the high growth segments, if you hear, is mobile phones. The volumes are big. India is probably the second biggest mobile phone market, worldwide. That's a big. Your wearables, hearables, that's going to be a big market because, India has this huge Gen Z population that is going to be going after all these gizmos. The third, which is very important market that is going to grow in India, is the military segment. So I think, India is trying to become, attempting to become a superpower. And given that, you need, if you see, we have been able to develop our own indigenous light combat aircraft. And you need a lot of electronics to go with that. You need the radars, you need the communication equipment, you need the drones to go along with that. All of which need a lot of semiconductors, and this has to be, developed. And there is already a push from the government and the ministry for Make in India. So in this segment. So if you go to any military organization, they will say if you make in India, you get a preference there. So that is, one of the key things, I would feel that could be a key growth driver. Apart from that, automotive. Automotive is growing. India is number 4 in terms of the automotive, the passenger vehicles in the world. So they were nowhere, and we are number 4. And many of us have two cars, so that itself goes to show that this market is actually growing.
Awesome. We're at the top of the hour. So any closing remarks on talent? There's no way we can talk about India's story in anything. And what you read about is that talent in semicon is not that much there. And I've been part of one journey. What is your view?
If you see, most of the fabulous companies, who have started the development here, they all have their roots in India. If you look at the IITs, if you look at the IAC, NITs, many of them. So why is, probably, no offense to other states or anything, why is Bangalore kind of sought after, for many of these engineering companies to come there? It's predominantly you have 52 engineering colleges there. You have almost close to 100,000 engineers passing out. You have talent available. So talent is available, but the question is, are we able to nurture the talent, provide all the support system that is available for this talent to, show their real prowess and other things. If it can happen, then I think India will definitely get there.
Thank you, Shankar. That was a power-packed conversation. I hope you enjoyed. I thoroughly enjoyed talking to you. You pretty much laid out a roadmap for India to say, we'll get more dollars out there or INR out of there to invest.
Absolutely,
Make sure the roadmap is slow and steady and be part of the global supply chain. Then say you'll do 110 billion, park a fab and think it'll happen. The nanometer, the node changes, and then you're looking for improvements and we'll all run for money. Talent is there, but of course, I think it's time to reorient. And there's plenty and plenty of room of innovation in this area.
The biggest benefit India will get is the saving in the foreign exchange reserves.
Awesome. Thank you. Thank you, NASCA.